Hi there, welcome to High School Maths. Today we're going to be looking at some basic Pythagoras calculations. So we're going to jump straight into the calculation and not go through any kind of theory. We're just going to jump straight into it. So there's two different versions of, or two different variations in Pythagoras questions. One where you're asked to find the long side, which is the hypotenuse, and one where you're asked to find the short side. So if we start off with this one, the right angle, the corner of the right angle, which is here, always points across to the hypotenuse or the longest side. Okay, so this is the hypotenuse or the longest side of the right angle triangle. If you're looking for the longest side, then we add. Okay, so we would add here. Now, your working for Pythagoras is always based around squares. So the basic idea is that a squared plus b squared, where a and b are your short sides, equals c squared, which is your long side. Okay, so I'm going to call my missing side here x, and because it's the longest side, x squared is going to equal 8 squared add 6 squared, because these are the two short sides. And your working follows through from that, so it's 64 plus, sorry, I'll just skip this, so we 64 plus 36, and that gives you 100. Square root that. Okay, so to get from x squared, we don't want x squared, we just want x. So the opposite of squaring is square rooting. Square root of 100 is 10 centimeters. So that's your Pythagoras working. Now you can actually cut out this middle line, this second line of working here, because that most of the time for Pythagoras you'll be able to do it in a calculator, or you'll be doing it in a calculator. Let's look at the second example here. So you can see here, our right angle again points across to the hypotenuse. So this is our longest side. If we call this y, our missing side here, then we're looking for one of the short sides this time. And if we're looking for a short side, then we take away. Okay, it's just a change of subject that's rearranging Pythagoras formula. So y squared equals 8 squared minus 3 squared. Okay, and it's a minus because we're looking for a short side of the right angle triangle. Okay, remember there are two short sides and one hypotenuse, one long side. So y squared equals, and that would be 64 minus, so again this time you can do this in the calculator, just type in 8 squared minus 3 squared, and that'll give you your answer for that line, rather than actually writing the kind of two separate answers out. So that would give you 55. Okay, so y squared equals 55. That's just typing this exactly as it looks into the calculator. We don't want y squared, we want y, so we square root both sides of the equation, and we get y equals the square root of 55. Square root of 55 is 7.42 to 2 decimal places, and that's centimeters. Okay, so that would be our two basic calculations for Pythagoras. One is going to be an add if you're looking for the hypotenuse. If you're looking for either of the two short sides, you're going to subtract. Now you're most likely going to see these in some kind of context. Okay, so let's have a look at the first kind of common question, which is an isosceles triangle, and it wants you to calculate the height of this triangle. So we've got an isosceles triangle here. This is 8. This is also 8 because it's isosceles, and it's 12 centimeters in the base. Now, what we want to do is not calculate the vertical height, not this sloping side. That's not the height. The height is from top to bottom. Okay, so what we're actually looking for, if we just draw a line, is the distance from here to here. Okay, now it's important that it's isosceles because that means you're splitting the triangle exactly in half. Okay, if it wasn't isosceles, you wouldn't be splitting it in half, you'd be splitting it so there was two different triangles. So if we look, and you can choose either one here, they're both the same, so I'm just going to choose the right hand side triangle. This part here is going to be 6 centimeters because it's half of the base. This part is 8, and now we've got a right angle triangle. Remember, when you need right angle triangles for Pythagoras, it only works with right angled triangles. So now we're going to look for this height h. Okay, so we've got two sides of the triangle. We can do Pythagoras, so h squared equals, and we've got to decide, is it an add or subtract? Well, that's our longest side, so this is the hypotenuse, which means this is a short side, so we're subtracting. So we do 8 squared minus 6 squared. Okay, hypotenuse squared minus the short side squared. So h squared equals 64 minus 36, and again we don't need to write that out, you can if you want, but that gives you 28. Square root both sides, so square root of 28, and then you get your answer. So square root of 28 is going to give us a decimal, so it's going to be 5.29 centimeters. Okay, so the height of that triangle would be 5.29 centimeters. Now, at the bottom it says, hence calculate. Hence just means using the answer you previously got. So hence calculate the area of the triangle. What it's wanting us to do is calculate the area kind of inside this shape. So it's combining this with your area topic. And the area of a triangle is half times the length times the breadth, or maybe a half times base times height, depending on what formula you've used. Same thing. So it's half times the length of the triangle, which is 12, times the breadth. Now you cannot use the sloping sides. When you're choosing your area, your dimensions for the area, they need to be at right angles to each other. So the 12 is the length, the breadth would be this distance here, or our height, which we calculated in part A. So half times 12 times 5.29. Okay, common mistake there would be people just doing a half times 12 times 8. That wouldn't give you the area of the triangle. Okay, so type that in again. So times it by 0.5, times it by 12, and we get 31.75 as our area, cm squared. Okay, remember, squared centimeters for our units for the area. Okay, so that's one instance where you can see Pythagoras come into play. Quite a common question. We've got an isosceles triangle. It could be equilateral as well. And you split the triangle in half and then use Pythagoras to find the missing dimension. Let's have a look at another one. So here we've got to calculate the perimeter of the kite. Perimeter, remember, is the length around the outside of the shape. So it's looking for this kind of black line here. Now we've got two sets of triangles. We've got the top two, which are identical, and the bottom two, which are identical. Okay, so what I'm going to do is I'm going to call this one X and this one Y. We don't know any of the lengths of these black lines, and we've got to find them out. Now, if we look at the shape, you have to look at it carefully, we can find our dimensions. Okay, so for this top triangle, I'm just going to focus on this kind of right-hand side one here that I'm highlighting just now. That part there, the whole kite is 12 centimeters tall. This little part here is 2. So that means this part, 12 take away 2, is 10 centimeters from here to here. From here to here is halfway across the whole shape, so, or half of the diagonal, so 3 centimeters. Okay, so if we focus on just this triangle, then we can find X. So X squared equals, it is the longest side of the triangle. It is a right angle triangle, you can see the right angle here. So X squared equals 10 squared add 3 squared. And I would always try and put the bigger number first. When you're adding, it doesn't matter too much, but when you're subtracting, you do want to always have the bigger number first. So it's just a good habit to be in. So 10 squared plus 3 squared would be 109. And again, it's just following that working after that. So 100 and square root of 109, and then type that into your calculator. So square root of 109 is going to be 10.44. Again, we'll just go to 2 decimal places, centimeters. Same idea for the Y. So we're looking at this bottom triangle here now. That part is 3, we already know that. That part is 2 from over here, so 2 centimeters. Okay, so we're just going to look at this little triangle here, and Y squared is going to be, again, there's your right angle. So it's going to be adding because we're pointing across to the hypotenuse, which is the longest side. So 3 squared add 2 squared. That's going to be 9 add 4, which is 13. Square root the 13, and that's going to give us our answer. So square root of 13 is going to be 3.61 centimeters. Okay, now what we were asked for is the perimeter. We know that the length of X is 10.44, so that side and that side are going to be 10.44. This side and this side are going to be 3.61. So the perimeter, I'll just write it out explicitly, 10.44 plus 10.44 plus 3.61 plus 3.61. And you're just adding them all together. So let's type that into the calculator. 10.44 plus 10.44 plus 3.61 plus 3.61. And it should give you 28.1 altogether centimeters for the perimeter, which is your final answer. Okay, let's try another question. So here, we've got our final example that we're going to look at just now. Pythagoras in 3D shapes, and we've got 2 missing dimensions we want to calculate here. Now this can be quite hard to visualize. We've actually got 2 triangles here. the one we're looking for here is C. That's the dotted line across the middle. So you can see there's a triangle. I'll try and highlight it. So you can see this triangle kind of going from here, excuse my shaky hand, to here, to here. And that would be a right angled triangle, okay, because down here, it's just drawn to a perspective. So that would be a right angle in that corner there. Okay, remember it's a three-dimensional box, so it's skewed to make the diagram look three-dimensional. Okay, so we're looking for this side here, C. And again, the right angle is pointing to this missing side, which means it's the hypotenuse, which means it's the longest side, so you're going to be adding. So your first step is C squared equals 10 squared add 6 squared. So even though the question looks completely different, you find your right angle triangle and you find two sides and then you do Pythagoras. That's the exact same working. So 10 squared add 6 squared would be 136. Square root it is a square root of 136. Type that into the calculator and that gives you 11.66 centimeters. Okay, so that's us found this dotted line across the middle. For the second part, we're then asked to find D. Now, if you look at this D here, that dotted line is what we're looking to find. We can actually see there's another right angle triangle, and this one might be a wee bit harder to spot, but it's standing up within the shape here. Okay, again, this would be a right angle. Might not look like it because it's again skewed because of the perspective of the diagram, but it is a right angle triangle. We know that C was 11.66, so it's 11.66 centimeters there. We know that this height is 3, and here is a line, here's a right angle pointing across to the line we're looking for, which means D is the hypotenuse, which again means we're adding here. So D squared equals 11.66 squared plus 3 squared, and we're using that previous answer for this question. So we're going to take our previous answer and we're going to square that, and then add on 9, or 3 squared, which is 145. Okay, if you kept your answer in a calculator, you will get that number exactly. If you rounded it, then you'll get a number very close to that. So D equals square root of 145, and square root of 145 is 12.04 centimeters. Okay, so that's your values for C and D. Now, for Pythagoras, there are loads and loads and loads of different possibilities. The right angle triangle is quite often hidden, so you'll have to look for it. But once you find it, the 4 lines of work can stay exactly the same. It's either a plus or a minus, depending if you're looking for the long side or the short sides. And once you've got the numbers, you just plug them in and work your way through. Okay, so hopefully you found that video useful, and hopefully you found it useful seeing those different varieties of questions. For other maths videos and resources, please visit www.highschoolmaths.co.